Alright, let's talk about special products and factoring. First of which is going to be conjugate binomials, okay? C-O-N-J-U-G-A-T-E, conjugate binomials. So binomial at 2, M-I-A-L, is going to be a polynomial with two terms, right? So we could have something like x plus 3 and x minus 5. I'm sorry, x plus 3, and the conjugate of that would be x and the 3, but instead of the plus we have a minus, okay? And when we multiply these two things, what happens is we do what's called FOIL, but there's a more general method. So x times x gives us an x squared. Then we do the 3 times x gives us a 3x, and minus 3 times x is a minus 3x. So we have plus 3x and a minus 3x, which are going to eliminate each other. And the last one, we're going to get 3 times minus 3, which is going to give us a minus 9. And this whole thing will end up giving us x squared minus 9. Okay? So these two middle terms drop out. That's the important part. We see this trick used a number of times. So now if we go backwards on this and we want to factor this back out, we see that's a difference of perfect squares, and we know that that's going to be two binomials to give us the x squared, and it's going to be an x and an x, and then the minus 9 has to be a minus 3 and a plus 3. Okay, so this is called the difference of squares, and we have a special, that's a special product as our factoring. So difference of squares. So once again, this needs to be a perfect square, this needs to be a perfect square. Difference is the minus sign in the middle, and then we know we'll have conjugate pair to do that. Okay, the next type of special product we have is going to be products of any binomials here. So let me start a new page. So in more general terms, if we're multiplying any two polynomials together, so we could have like x squared plus 3x plus 5, and let's multiply that by x squared minus x plus 2. Okay, so what we want to do now is multiply every term by every other term. So I'm going to take this x squared, multiply it by x squared, and also multiply it by a minus x, and multiply it by a 2. Okay, so those two things are going to give me x squared times x squared, which is x to the 4th. The second one's going to give me 3x times a minus x is going to be a minus 3x squared. And the okay, wait a minute, made a mistake. Let me go back here. Okay, let's try that again. So we still have this x squared times x squared, which gives us x to the 4th. We have x squared times a minus x, which is going to be a minus x cubed. There we go. Found the error of my ways. And then the third one, we're going to have x squared times a 2, which is going to be plus 2x squared. Okay, next, we'll try a different color to see if that helps. I'm going to take this 3x and multiply by everything. So 3x times x squared is going to be 3x cubed. So we're going to have a 3x cubed. And notice I'm lining these all up vertically. Okay, next one I'm going to take the 3x times a minus x, which is a minus 3x squared. And then the last one is going to be the 3x times the 2, which is going to give me a plus 6x. Okay, and last time we're going to multiply the 5 times the x squared, which is going to give me 5x squared. We're going to multiply the 5 by the minus x, which is a minus 5x. And we'll multiply the 5 by the 2, which is a 10. And now if we sum all this stuff together, we'll get x to the 4th. We'll get 3x squared minus 3x squared minus, or 3x cubed. I have a problem here too, excuse me, that's been a cube. So 3x cubed and a minus x cubed is going to be plus 2x cubed. And in here we have 5 minus 3 plus 2, so that's 0. So we, no, I'm sorry, 5 plus 2 is 7 minus 3 is 4. So we're going to have plus 4x squared, which is a cube. I keep forgetting that. So it's 7 minus 3 is plus 4x squared. plus 6x minus 5x is going to be a plus x and a plus 10. Okay, so that works even if we have 4 terms in here, or 5 or 6, and it works for anything. So this is the general method and the one that is preferred. Okay, finishing up our special products. We want to see the formulas quickly and maybe one example for difference in sum of cubes. So let me do that one next. So we have a formula. If we have a difference of cubes, something like x cubed minus y cubed, right? Difference of cubes. Okay, to do that, we need a formula over here, which is going to give me an x cubed minus y cubed. Or let's do this. We're going to call it a cubed and b cubed. So this is more general. Okay, a cubed minus b cubed is going to give you a minus b. Okay, because that's a is the cube root of a cubed, b is the cube root of b cubed. We keep the sign the same. Then over here we are going to square the a, so we get an a squared. We're going to multiply the a and the b together with the minus sign. That's a minus ab, and we want to take the opposite of that, so it's going to be plus ab. And lastly, we'll take this b and square it. So minus b and minus b is a plus b squared. Okay. And then the other one is we have the sum of cubes. So if you have 2 terms that are perfect cubes, a cubed plus b cubed, it's going to give us the same formula with a slight difference here, mainly a plus b now, still the cube root of each of these terms, a and b, and we follow the same rule. We're going to square the first one, so we're going to get a squared. We're going to multiply these two together, a and b, but we're going to change signs. So we're going to have minus ab now, and we'll still multiply the b by itself and get a b squared. Okay, b squared in there. And be careful, this is not the same as x. What do I want to say here? This is not the same as x minus y cubed, okay, or squared. Never mind this last part. This should be fine for what you need to know for the test. Okay, and this concludes this section. Thank you.